welcome to this Doppio build video. In this video we're going to build a Doppio together. Before we begin, let's take a quick look at all the components that should be in your kit. First of all, there's the PCB panel, of course, the front panel, the back panel. This is the 3D printed baffle for the LEDs, a 3D printed spacer, which will go over these switches. It's Tom from the future here, so I'm editing the video and I just noticed that while I was shooting the build video, since then I've made a little change to the LED spacer and baffle. Just know that I've detailed this in the build guide, and here's a picture of the new version. Okay, so just keep in mind that with the new version, you have to snip the two parts in two, and then you'll have an LED, baffle, and a switch spacer. Okay, let's carry on with the video. These are two stereo pods. For these we have two knob caps and both a spacer and a nut. There's two M2.5 screws, one shorter, one slightly longer, 4 Donkey Kong jacks, and for each of these jacks there's both a washer and a nut. Then there's 4 M2.5 spacers, a power connector, so that's a pitch 2.54 millimeters, and then all the other connectors are pitch 2 millimeters, 3 male connectors and 3 female connectors, and then finally there's a power cable. So before you continue with the build, please make sure that all of these components are in your kit, and should that not be the case, please contact the party from which you got the kit, be that myself or one of my retailers, and we will sort you out. Okay, so assuming that everything's there, let's move ahead. Here is an overview of the tools you will need to build this kit. A pair of pliers, a pair of cutters or snips, a Phillips head screwdriver, a small flat screwdriver, 2 patch cables. The length doesn't matter, but shorter ones are more practical for our purposes, some solder wire, and then a piece of foam or cardboard. So, of course, you'll need a soldering iron. Doesn't need to be a fancy one like this one. Just keep in mind that you set the temperature correctly. So, the first thing we're going to do is depanel these boards. That'll make them a bit easier to work with. So I'm going to use my snips to do this. Be mindful though, when you're doing this, there's some fine particles leaving these cuts. Make sure you don't breathe that in, because that stuff is not really great for your health, okay? There we go. First the outsides, and then the inner mouse bites. Don't worry that these cuts look a bit ugly. It's not that important at this point. We can now use the pliers to break off the rest. If you're really meticulous about getting a clean finish on the edges of your board, you may also get a file and file down the rest of the cuts. That will properly clean them up. It's functionally not required, but I prefer to do so. Okay, so now the boards are depaneled. As a first step, I'm now going to mount the female connectors on the first board. So I'm going to take my little piece of foam. We're going to flip the board because these connectors need to go on the back. We put them there, and now we're going to use the foam to keep the components in place as we flip it. Okay, so I'm going to solder one pin. At this point it's a bit janky, but don't worry about that. It's okay. It's part of the DIY experience. And then here we press the board down a bit so the pins stick through. And now these connectors will stick to the board. They may just not be perfectly square yet, so we need to check. The easiest way to do this is tapping them with your finger, and if they can still move a bit downwards, that's a sign that they're not completely square and in line with the board. So what I typically do then is put one finger here. And I'm going to heat this solder joint again. And now I can feel it click upwards with my finger as the connector becomes flush with the board. Other than that, I think all of these are looking good, so we can now solder them. Take care to not touch the solder joint you made earlier. You can retouch that one as the last. So I'm going to start here. So if you don't have fume extraction, blow at your soldering iron to get rid of the fumes. Okay. So another nice thing about the foam is that it helps you easily manipulate your workpiece. Don't worry too much about these bridges. We will solve them later. You can drag your soldering iron over these bridges and then we can reflow them. The important thing here is to avoid heating up these connections for too long. You can use my example here as a reference, but well, it's not even that bad if you heat them a little bit longer, but don't go heating these up for minutes because that may damage the connectors, that may cause the plastic to melt on the other side of the board. Let's now put the connectors on the second board. As you may see, these have two sides. So this side here with the small protrusions, that's the part that goes into the board. So the flat side should be pointing upwards. That's very important. If you don't do this correctly, you may have connection issues between the board. Let's put them in place. We'll use the same technique with the piece of foam to flip the board just as we did with the other board. We're going to, again, solder one pin per connector. And now we're going to check if these connectors are flush. It seems to be pretty okay in this case, but just when in doubt, it doesn't hurt to reflow them the way I showed you earlier. The important distinction with the female connectors is though that you should avoid touching the pin that you're reflowing with your finger, because that may cause things to smell like bacon. And if it smells like bacon, you're not doing it right. Okay, so now I'm completely confident that these are flush and I can solder the rest of the pins. Got some bridging there. And again, be sure to clean your soldering iron regularly. Then it optimally makes use of the flux that's inside the solder wire, and then it's easiest to solder. Okay, let's now briefly inspect these solder joints. these ones are a bit, could be better, so I'm going to add a little bit of solder and reflow them. From my experience with regards to the success of these kind of kits, usually most faults I find in the solder joints of the connectors between the boards. So really take your time to check these closely. For sure it's going to pay off later. Okay, so the next step, we're going to solder the trimmers. They go here. Oops, there we go. Same technique to flip the board. Now you may notice that these trimmers will not sit entirely flush. Well, maybe not necessarily. It's not really functionally required for them to sit flush. So either you can, at this point, just solder all the pins, or just with the same as with the connectors, I like to touch them with my finger, push them gently so they sit flush, reflow the solder joint, and then now that I've felt with my finger that they are completely flush, I solder the other two pins. All right, so let's take a look. These sit nice and flush, so that's a good thing. Yeah, so now we're going to snip off the legs of these trimmers. Okay. The power connector, quite essential. So, yeah, we're going to solder this guy as well, and then this board is as good as finished. So, to use the foam here. Mind you that this connector is a bit more difficult to solder than the other ones, because there are massive internal power planes connected to this connector, and they take a while to heat up. So the outer two pins, they're easiest to solder. The middle the middle 6 pins, they're connected to ground, and they are a bit trickier. So the same as with all my connectors, I'm going to solder a single pin. So as you can see, it takes a bit longer before that reflows. I'm going to check if it's nice and flush, and to be sure, I'm also going to reflow it so it sits nice and flush with the board. Yeah. Now I will solder the outer two connections. Don't worry about the bridging, we're gonna solve that in a bit. And now we can solder the inner pins. You'll notice that this gets a bit easier as you solder more of them, because the internal power plane is also heating up, and that's okay. Also, be sure that to maybe not touch this region of the board, because the heat put into soldering these pins is going to warm up this whole section. So be sure not to touch that right away, as well, it's not going to cause the smell of bacon, but it's not going to be pleasant, let's say. All right, back to the first board. Now we're going to put this baffle on. You put the longer screw in the baffle, you push it through, and then that fits over here. Then you need to take one of the standoffs and screw it to the back. Right, I'm going to take my screwdriver and gently tighten that. Don't over tighten this, just make it snug enough so that you can't easily loosen this standoff with your hands. All right, so now we're going to do the same thing here on the bottom part with the short screw and another standoff. So as you may notice, at this point, this board is not able to sit upright anymore. So it does that. Now, here's an easy hack to deal with that. Take your pliers and rest the board in between. So this way you can still easily work on it without it tipping over. Now we're going to put the jacks in place. So important, make sure that you put the screw here before you install the jacks, because it's a pain to get that screw in while the jacks have already been soldered. So these switches, they have two sides, one with some labeling and another one without. Personally, I like to have the labeling on the inside. It doesn't matter functionally, but that's what I like to do. Then you put this 3D printed spacer over the switches. It's important to press them down firmly so that they're sitting flush. Then it's time to put the stereo pots in place. It's a good idea to, while you're at this point, to really double check if these solder joints are okay, because they will be a bit tricky to reach afterwards. I see that here in this case, this one could use a little bit more. It's probably okay, but you know, just to be sure and not have to mess around later, I am going to give this some extra love. And yeah, that may cause some extra bridging, but you know how to solve that. Time to put the pots in place. Then put these two washers over the shafts of the pot. That will make the front panel sit flush with all the other components. And now it's time for us to put on the front panel. There we go. So you may notice that these things don't initially line up perfectly. Take your fine screwdriver and poke them around a bit until everything does. And now I'm going to put the nuts for the pots over their shafts, and I'm going to tighten them. I use one of these, what do you call these? Hex sockets to do that. The ones from Wera, they are very good at not damaging the front panel components. If you don't have a hex socket driver, you may consider one of these pliers. Just make sure that you put masking tape over these parts so that you don't scratch up the front panel, because you'll kick yourself later if you do. So for now, I will just use this hex socket driver. I know it's an electrical one, but you can get manual versions of this. It's just what I have lying around here in the workshop. So as a next step, we're now going to add washers to the jacks. Oops. And the jack nuts. So it's important that these things have slots on the top. it's important that you keep them on the top. So either you can hand tighten these, or you can also have special tools to tighten these. I've had one custom made. That's the engineer's solution to this kind of problem. So now I'm going to tighten them. So just as a reminder, you can perfectly hand tighten these, but I just like to do it this way. It is important though that you use your thumb or another finger to keep this jack flush as you apply force, because applying force may cause this jack to go a bit out of alignment, and then the body will stick next to the front panel, and you don't want that. Now everything is securely in place and we can solder. Same thing here, to keep this sitting upright and easy to work on while soldering. If you don't have a kind of fancy vise like a panna vise, you can just use pliers. First, we're going to solder the pots. Don't worry about the bridges. There's only happy accidents, as Bob Ross would say. Right, now we're going to solder the switches. Be careful to not touch the plastic of the connectors. It's possible that you may need to rotate your workpiece a bit, but it can easily be done. So take your time, make sure you don't melt any plastic. And now let's solder the jacks. These two, they may be a bit harder to solder. They're connected to ground. Just so you know, that's okay. Also, if you get a bridge between these two, that's perfectly fine. They're connected to ground, both of them. So. And now the final thing remaining to solder are these tabs for the pots. Functionally speaking, it's not really mandatory, but it just gives some extra rigidity to the pots, so I generally like to solder them. Time to inspect. I think all of this is looking good. Now we can piece the two boards together. If you soldered the connectors perfectly flush, this all lines up perfectly. Gently push it together. Now install the extra standoffs. Then we can add the back panel. So you should take care to align the hole in the back panel with the serial number. And then finally we can add these nuts. If you tighten these with the tool, make sure to put tape around the tool so you don't scratch the back panel. The module is finished now. We can calibrate it now, and then it should be ready to use. The module now is ready for calibration. However, there's still two things we need to do. First of all, we need to add the knobs, very important. Turn them completely counterclockwise and then place the knobs like so. Then it's important to correctly install the power cable. As you will see, the power cable has a red wire. It's important that you connect it to this side of the module. So it's indicated with a thick line here and also with a lightning mark. Be sure that the power cable is connected in this orientation. If you don't get this right, the module won't blow up, but it won't function either. Make sure that you get that right. To do the calibration, I've gotten my little Doppio case here to use as a power supply. I'm now going to connect it. The case is not powered up yet. So never connect cables to the power supply of a case when there is power applied. Now it's been connected. Rotate the module so that the trimmers are facing upwards. I will now apply power to the case. No magic smoke, that's always a good sign. We're going to manipulate the trimmers here and there. So we want to make sure that they're facing towards us so we can turn them. So the goal of the calibration is the following thing. So because Doppio is DC coupled and does have quite a bit of gain, especially when chaining signals, chaining the channels, you get a thing called a DC offset. And that may cause some weird effects when you're doing this high gain chaining. And to avoid that, we're going to use these trimmers to get rid of that DC offset. Let me show you how. So we need to make sure that volume and gain are at their maximum setting. We want to make sure that this switch is also set to the maximum setting, so times 21. The setting of this switch does not matter. Now we're ready to calibrate the DC offset. For the first channel, we're going to take a patch cable and chain channels A and B. So the output of channel A is going into the input of channel B. And as you can see, this has now caused the green LED on channel B to light up. So this is not because there's a lot of noise there or any kind of real signal. It's just because of the DC offset. So now I'm going to use my fine screwdriver and use the A trimmer to get rid of it, and we will effectively get rid of this when this LED goes out. Be careful not to slip while doing this. So you can turn these trimmers quite some turns in both directions. But in this case, we're lucky, we're close by. Ooh. So a little bit more, and then it's off. If you turn it further, it's possible that it goes back on again. So then you need to return to the middle there somewhere. Okay, so that's channel A. Let's now calibrate chaining in the other direction. So the output of B going into A. As you'll see, this causes the LEDs to light up. And the reason for that is that the input of B is normaled to the input of A. So we first need to ground this input to properly be able to do the calibration. So for that purpose, Take a bit of solder wire, just either snip that off or break that off. Take a second patch cable, and now you're going to wrap the solder wire around the tip and sleeve so that you get a connection between the tip and the sleeve. So it doesn't necessarily need to be pretty, but as long as you get a connection, it's okay. And now I'm going to put the other side of this cable into the input of channel B, and you can clearly see that that caused all the other LEDs to go out, except for the green LED on channel B, and that one is lighting up due to offset. So now I'm going to use the channel B trimmer to get rid of this. Oops, so that little click you hear there, don't know if you're gonna hear that, but that means we're at the end of the range. So now I'm turning in the other direction until the LED goes out. And just the same as with the A trimmer, if you continue along too far, it may light up again. So we need to be somewhere right in the middle so that it's off. It is possible that if you change the maximum gain to ×5, that the green LED will light up. That's perfectly normal. We're only calibrating this for the highest gain mode. See, so in this case for channel A, the LED lights up. It doesn't for the ×21 gain setting. We're calibrating it for the highest gain setting because that makes sense. If you do twice ×5, you get ×25, and that's so close to ×21 that there's really little use case for using the ×25 setting when the channels are chained. That's it really. Your module is ready to use now. I hope you'll enjoy it. And yeah, if you make a cool patch, be sure to share it. I love hearing and seeing the stuff that people make with my modules. Okay, well, I really hope you enjoyed this build, and yeah, I'll see you in the next one. Have a great day, everybody. Bye-bye.